Hey everybody, this is Larry. This is day 11. Okay, well, September 11th of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Don't have that much energy today. I did a late run, 11 miles. Not that much, but a lot of it was a little bit fast. I mean, like as intended, but it just takes a lot of me. And the temperature here is just a little bit odd. It's not too hot, but it's also like, I don't know, maybe it's just my body as well. It's just like I get cold way soon afterwards, and it's not even that cold, but I don't know. Everything is a little bit chaotic, so I'm just a little bit not feeling that well. Maybe I'm just running too much and just need to sleep, which is why I'm gonna go over this very quickly. Yeah, I mean, it is September 10th here in New York, not quite 11th. So I'll probably do my spiel tomorrow. I grew up in New York. My high school was a couple of blocks away from the World Trade Center. So it always is a little bit, yeah. I won't talk about it today. But yeah, even though it is the 11th video and the days are a little bit weird when they launch these. So yeah. And also today's a easy problem, so hopefully it'll be easy. Let's get to it. And I'll probably do an extra one afterwards just because if it's a easy, then I should get some, get some exercise in. But yeah. Okay, a bit flip or 2020, 2220. I can't even. There are too many twos in that number. I get confused. Minimum bit flips to convert number. A bit flip of a number x is choosing a bit in the binary representation of x and flipping it from 0 to 1 or 1 to 0. Okay. We know what a flip. Oh, excuse me. Given two integers start and go, return the minimum number of bit flips to convert start to go. So I think I did this during a contest once. I probably just did an XOR and counting the bit count or something like this because I wanted to sound cool, and that's probably that's actually what I did. But XOR is just like the reason why XOR works is we can come up with a truth table, right? I think one thing that I would say about bitwise operations is that they're pairwise distinct, right? For them, yeah, if you do them correctly, they're pairwise distinct. And what I mean by that is that every bit is for itself, right? Like the bit on the zeroth, like if you do an operation on the entire number, the zeroth bit only matches up with the zeroth bit, first bit, and so forth, right? So like they don't affect each other, unlike arithmetic operations like addition or something like this, right? And so the first thing to do, yeah, and it comes from experience, but you can also just do a classic thing that you did in class, which is a truth table, right? So basically, one thing that we want is that, okay, so if we want to go from start to go, so let's say this is start, or maybe just I'll keep it A, B. A is start, B is go, right? Then if A is on a per bit basis, if there's 0, then no action, right? If they're 1 to 0, then 1 action. 0 to 1, 1 action. Or 1 to 1, 0 action, right? And that's pretty much it. And yeah, you can do it with XOR if you want to get fancy, and you can kind of figure out how this looks, right? No action, maybe you can encode it to a 0. You can encode this to a 1. You can code this to a 1, and you can code this to a 0, and you have 0, 1, 1, 0, which with any experience you'll recognize as an XOR. But you don't really need to do it this way. You could do it one bit at a time, right? So here maybe we do while start is greater than 0 and go or go is greater than 0, right? What's it called? Flips is equal to 0. So then now we just take the last bit one at a time. So if start mod 2, right, is not equal to go mod 2, then we need one flip. Basically, we're just looking at the last digit one at a time, and then otherwise we do it by 2 on both sides, so that we can look at the next bit. And that's really pretty much it. You can be a little bit clever. I even did one line prior to the contest, I think. Though, wow, that was 2 years ago, 2.5 years ago. Time really do fly. But yeah, give it a quick submit. Pretty straightforward, nothing to it. Yeah, it's just about kind of just writing it out, and after you write it out, things do get, you know, you have a template, you know what to do, then it becomes okay, right? And this is a good practice for this kind of problem. Yeah, what's the complexity here? It's going to be linear time, technically log n space. Linear time, because remember, the size of the input is the number of bits, right? So it's going to be linear in the number of bits, but flips will only take log n bits, right? Because the biggest number can be log n, and log n, or log as the log of the input, and so the number of bits representing log of the input is going to be log of the input, right? So, it's, but the input number, so yeah, so it's just going to be log n bits. Yeah, that's all I have for this one. Let me know what you think. Thanks for watching. I am so yeah, I just don't have energy today, but I'll try to do one more. So stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.